Section 4.3 focuses on grippers. Baxter grippers can do either open or close or keep an exact position ranging from 0 to 100. All of these three functions can be done by publishing a command to a specific topic. That topic can be found here. It's robot end effector, the side of the arm, either right or left, underscore gripper command. If we do a ROS topic list, we can do an initial pipe with a grep for gripper, which will give us a lot of topics like that. But then we can do a second pipe and say command. This reduces the number of topics that we get, and you can see that we have a robot end effector, left gripper, and right gripper command. When we look at the type of this topic, it's going to be a Baxter core messages. In fact, most of the messages used by the Baxter robot are defined within this Baxter core messages library. This one specifically is called end effector command and has this basic outlook. It has an initial ID that it requires in order to identify the type of gripper that it is. In Baxter Robot, you can have electric grippers or suction grippers. The website has the appropriate ID code. Then we need a command, whether it's to grip or close the hands, release or open the hands, go to a specific position, stop, and many more. We can also provide the arguments, meaning the position that where we want that gripper to go. So if we just do a ROS message show Baxter core messages, we can see that we get quite a number of these. And so here we can use the end effector command that we also find right here. You'll see that there's more types of commands that I listed, but the basic concept is right here. If we command the grippers to either grip or release, but we also have an object between the fingers, the robot's controller is designed to close or grip the object firmly until there's no more slack. So this results in a firm grasp, and it's ideal just for grasping objects. As part of our code in the book, we implement a special C++ interface that simplifies the code base by abstracting the subscriptions and publications to ROS topics. We did something similar in our previous chapter when we worked with planners. So the code for such an interface is found in this simple Baxter gripper interface package, which I can show you right here. In part 5 of the book, under the Baxter folder, we have this package, simple Baxter gripper interface. Okay, and if we want to look at that code base, we can always just run roset simple Baxter gripper interface. And then a file by the same name. Come back here. In the PPT, I'll give you a quick overview of this code. Number one, it's important that we create a message for the gripper. So we create a Baxter core messages end effector command gripper. End effector command, and then variable called gripper command open. And then we can access all the internal fields of this object to define parameters. So for the electrical gripper, we can use this ID. And then sequence, this is negligible parameter. Here we set it to 2. We can say the command go, and then set arguments in this way, position 100, So this will open the gripper completely, and then if you want to include a sender message, you're free to do so. So that we do not need to worry about publishing and subscribing, we can use these two, initialize subscriber and initialize publishers, where we create the objects and assign the right topics or callbacks for publishers and subscribers. Once we do that, the publications, for example, will be advertised, and we can just simply continue with our code. As part of the class and our public methods, we can simply call a right gripper close, right gripper open, or left gripper close, left gripper open. What this will do is actually call the publish method on the publisher object with the appropriate message, and so this will immediately trigger the arm to make a movement of opening or closing. We can also check the state of the command gripper by going to robot end effector, right or left gripper, and then state. Very similar as before, but now we're using Baxter core messages end effector state. One thing to notice, this is important for the callbacks, is that the gripper state may be damaged by noise that comes from the actuators. So in our callbacks, we included or implemented a low-pass filter. The low-pass filter is of this type. The output here, position filter, is multiplied 1 by minus some argument x that goes from 0 to 1. And then we add that same value x to this product x times the current position of the gripper. So imagine if x has a value of 1, this term is cancelled, and then you always get the current position from your sensor. If x was equal to 0, this position would always be cancelled, and you would just end up with the original number that was provided here, normally initialized to the same value as the very first current position. So this is a way to weigh whether we want something that is more towards the latest reading or towards the previous reading. Okay, so just to highlight the code, here we have the callback. We're taking in the gripper state, and so we represent this equation like so. We can run a test code to see that this code is working properly. This is part of a simple Baxter Gripper interface, and the client is called Baxter Gripper libtest main, and it'll show us how the robot can open or close his hands. So let's go over there. Rush run simple Baxter Gripper interface, Baxter Gripper libtest main. It's possible we need to enable the robot here. Right now it's not functioning, so let me try to enable the robot one more time. Let me kill this code, which is getting stuck. One way to do that is look at this process using these variables, then running a grep on that. Here we might do gripper, for example. We need to be careful which of these processes we get. This is the spawner. This is the spawner. Not this one. This one is the right one. So it would be this PID. Then we can run kill with that PID. Once we do that, we see that this code has restarted. Also, maybe let me move those arms real quick. see if we get a better view of our gripper. This code that I just ran will not be available to you immediately, but simple to use. Okay, that's a little bit better view. Let me run that one more time. So now that we've enabled the robot, you can see that we are able to open and close that gripper. If we want to see the state, we do a ROS topic echo, robot, right. Sorry, let me look back at our topic here. Robot end effector, sorry. Right gripper state. So let's run this code one more time. You can see that that position is changing when we move the robot, going from 0 to almost 100. There is almost 100, and again down to 0. So this is how the Baxter gripper works. That's all for section 14.3.